Assalamualaikum. Now I will show about RLC, resonant circuit analysis using MATLAB. This is our group member. The figure show a series resonant circuit that have resistance, inductors and capacitance. By using Kirchhoff voltage law, negative V plus IR plus I j omega L plus I 1 over j omega C is equal to 0. Negative V plus I in bracket R plus j omega L plus 1 over j omega C is equal to 0. Where Z is equal to R plus j omega L plus 1 over j omega C. Then negative V plus I plus Z is equal to 0. I equal to V over V in bracket R plus j omega L plus 1 over j omega C. I is equal to V over V R plus j in bracket omega L plus 1 over omega C. As we can see there, current transfer function is proven. I is equal to Vs is over V0. Now this is the frequency response. Modulus I equal to modulus V over V modulus Z. Modulus Z is equal to square root R squared plus X squared. Then square root R squared plus in bracket omega L plus 1 over omega C square. I is equal to I modulus is equal to Vm over V square root R squared plus in bracket omega L plus 1 over omega C square. Now we show about a resonant frequency. SL is equal to XC. V0 L is equal to 1 over V0 C. V0 is equal to 1 over square root LC. This is the quality factor. Q is equal to omega naught L over R is equal to 1 over omega naught CR. The bandwidth is B is equal to R over L is equal to omega naught over Q. Okay, now I will show about the MATLAB that our group have done. This is what we call that the coding. We use Vm equal to 0, capacitance equal to 4, R equal to 4, L is equal to 13. Then we click here to prove that our coding is not wrong. Yeah, not wrong. Now we click here, then we click at the peak there, right? So we compare the X value that 0.131 with omega naught 0.1387. It's really near that is correct, approximately. So we close for a while, then we try a second value of R. We use 6 and we click run, and we see the graph we get different. So we do same as before this. We click here, then we click at the peak to compare the X value that we get 0.1346, that is near or as known as approximately with omega naught, that is 0.1387. It's really near. So we click close to try the last this. Okay, so we use this the value is 10. When we click a run button, and we see the graph is a bit different. Yes, when we click same like before this, and we click the peak value, we get 0.1222 that with omega naught 0.1387. Yes, really near. So we close then we click word, then I will explain about this. Function of series resonant circuit. One of the purpose of a resonant circuit is to establish a condition of stable frequency in circuit designed to produce AC signal. Another use of resonant is to block a frequency and range of frequencies, thus acting as a sort of frequency filter to strain certain frequencies out of mix of other. It is a value that we get at the graph. That is, when we compare 3Ds, the quality factor value is a Q2. Second quality factor, as its value is the highest among the three. Resonant circuits are used to respond selectively to signal of a given frequency while discriminating against a signal of different frequency. If the response of the circuit is more narrowly picked around the chosen frequency, we say that the circuit has higher selectivity. A quality factor Q is a measure of the selectivity. Okay, that's all for our explanation about the RLC resonant circuit using MATLAB.
Thank you.
Thank you.